the range of our function h, which is defined to be the square root of 4 minus t squared. This is h of t. Okay. Recall that range of the function h, by definition, is the collection of all those elements t. Let me write y, such that we can write y as h of t for some elements t of the domain of h. This is the definition we gave for range of a function, and that is what it is. Using this definition, we know who domain of h is. This is the interval -2, 2. So, if t is in this interval, the highest value of t squared is that, so t squared is less than or equal to 4, as long as t is moving here. But the smallest value it can take is 0. So t squared lies between 0 and 4. Alright. What does this mean? This means that our 4 minus t squared, when you take the square root, what you get is in the interval 0, 2. And that means that the range of the function h is equal to 0, 2. This is the range of this function. So you can check to be sure, to convince yourself. For any element you take here, when you compute 4 minus t squared, where t is what you take here, and you take the square root, what you get lands here. For example, if you take t to be -4, if t is -2, then t squared is 4, so that 4 minus t squared is 4 minus 4, which is 0. And that means square root of 4 minus t squared is square root of 0, which is 0. The same thing will happen if t is 2. T has the least value if t is 0. So if t is 0, 4 minus 0 is 4. You take the square root of 4, you get 2. So as the values of t increase, 4 minus t will decrease, so the square root will also decrease. And so the highest value you can get for the function h occurs when your t is 0. And if t is 0, you get 4 minus 0, you take the square root, you get t. So every other value you get between here lies between 0 and 2. So the least value you can get for that matter is when your t is either -2 or +2. And so the range of this function is this interval. I always say, when you watch the video and then you have any question, drop it on the comment section. Somebody is there to alert me of the question you raised, then I respond. I answer the question. Don't, be afraid to do that. Also, if the video is good for you, because I know it will, just like it and then share it to your friends so they can learn from you too, from what we're doing as well. Still looking at another example. The more examples we take, I believe it will help us to be familiar with these concepts, and then we have less questions to ask when we follow the video very attentively. Look, let me take f of x to be 1 minus x if x is less than or equal to -1, and I take it to be 2 if -1 is strictly less than x, and this is less than 1. And I take it to be x squared plus 1 if x is bigger than or equal to 1. The question is, find the domain and range, and the range of f. That's our goal, to get the domain of this function and get the range of the same function. Okay. If you look at the way this function is defined, we define it piecewise. So a function defined this way is called a piecewise function. So a function defined this way is said to be defined piecewise. Excuse me. To get the solution, first we try to locate the domain. So we need to consider the different pieces. From here, we see that all x less than or equal to -1, I think I better use the number line to help us feel what we're doing better. So all x less than or equal to -1, so we are here. The value of f at x here is 1 minus x. For x between -1 and 1, excluding -1 and excluding 1, so I am here. So between here and here, the value of our function is 2. So our function is constant function 2. For x bigger than or equal to 1, that means from here to plus infinity, the value of our function is x squared plus 1. If you look at the way I broke it in 3 parts, you see that this function can take is defined for every value of the set of real numbers. Because this is what we have, negative infinity, comma, -1, union, -1, comma 1, union 1, comma plus infinity. So when you take the union of these 3 sets, this will generate a set of real numbers. And so the domain of our function, f, is nothing but the whole of R. This function has the value 2 for any element of this interval. So what it means is that this is a constant function. As I explained in class, the definition of a constant function. So I'm happy this example is here, so we understand how constant functions behave all the more. Look, f of 0 is equal to 2 because 0 is a member of this interval, -1, comma 1. f of half is also 2 because half belongs to this interval, -1, comma 1. f of -1/3 is 2 because -1/3 is a member of this interval. So if this continues like this until you exhaust all elements of this interval, you continue to get 2, 2, 2, 2. So that function is a constant function. So this is an example again of what a constant function is. Now, let's pursue getting the range of this function. And to do that, we need to examine what this function does in each of these pieces. So we know that when x is between -infinity and -1, what this function does is to remove x from 1 and give us something. And so we need to solve the problem there and to get the range.